Today I am going to talk about Gauss Elimination Method. Here I will solve the system of equation. Here is the problem statement. Solve the following system of equation using Gauss Elimination Method. Like 2x plus 3y minus z is equal to 5, 4x plus 4y minus 3z is equal to 3, 2x minus 3y plus 2z is equal to 2. We can write in the general equation like a11x plus a12y plus a13z is equal to b1, a21x plus a22y plus a23z is equal to b2, a31x plus a32y plus a33z is equal to b3. Now we can write matrix A, that is called coefficient matrix. So A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. So we can put the numerical value like that. X coefficient is 2, so 2, and then coefficient of y is 3, z coefficient is minus 1, like that. So 2, 3 minus 1, 4, 4 minus 3, 2 minus 3 and 2. Now this 5, 3, 2 is actually a column matrix, or we can say a constant matrix, so that we can write as a B. So here I already gave that matrix, so matrix B is nothing but B1, B2, B3 is equal to 5, 3, 2. Now after that we have to form the augmented matrix. Augmented matrix can be formed right side by side A and B matrix. So here A1, A2, so now this A matrix and this is B matrix. Now we can form the augmented matrix. Now here A11, A22 and A3 actually the diagonal element, and below the diagonal element we have to make, so A21, A31, A32 we have to make 0, 0 and 0 and form tridiagonal matrix. So that is actually Gauss elimination method. So we have to do that. Now here first we have to identify the pivot element. So here in the diagonal, so A1, A2 to A3 is the diagonal element. So the first element here we are considering as a pivot element. So A11 must not be 0. If it is 0, then we have to change the row or column. Now here pivot element A11 is equal to 2. Now we are going to, so first we are going to make this element A21 is equal to 0. So now for that we have to do the row operation. So now right now here step number 3, perform row operation to make the element in that 211 position 0. So A211 becomes 0. So we have to do the row operation. So first we have to find, or we have to calculate the multiplier. So this is actually called the multiplier. Always first when we do the row operation we have to calculate multiplier. Okay, so that is called multiplier. Okay, so that is, we can write also M. This is M1. We have to write how to do that, how to find the multiplier. So this is pivot element. Okay, and so this row first element, so which one we want to make 0, so that element. So A21 by A1 is the pivot element. Okay, so this pivot element that is called multiplier. So multiplier always be constant, it will not be changed throughout the operation. So A21 by A1 is pivot element, so A21 by A1 will be the multiplier. So now A21 is 4 and A11 is 2, so that multiplier is nothing but 2. Now we have to do the operation. So now here R2 means new R2. Okay, that will get from R2 minus multiplier into R1. Now here I am doing that operation. So A21, so A11, A12, A13, B1 will be as it is. Now we are going to make this element 0. So A21 minus A21 by A1 into A1. So here A1 will cancel out and this becomes 0. And we will have to do that operation each means this particular row, as we are doing that operation for this element. So we have to do all this element of the particular row. So A22 minus A21 by A1 into A12, A23 minus A21 A1 into A13, and B2 minus A21 A11 into B2. So you can see, so that multiplier, it has always constant value. So this is the multiplier, this is also multiplier, and this is also multiplier, this is also multiplier. So throughout the operation, multiplier value doesn't change, that is constant. Now, and then third row will be the as it is. So now 2 3 minus 1 5 is the first row. Okay, and then 4 minus 4 by 2 into 2, 4 minus 4 by 2 into 3, minus 3 minus 4 by 2 into minus 1, 3 minus 4 by 2 into 5. So, and third row 2 minus 3 2 and 2, that will be as it is. Now after doing the calculation of the second row, what we will get, that is in the next. So you will get this element 0. Okay, now so 2 3 minus 1 5 as it is 0. So now row 2 has changed, row 2's elements has changed. So 0 minus 2 minus 1 minus 7, 2 minus 3 2 is and 2. Now next is perform that second row operation. Now here, so this is 0, we already did that operation. Now we have to make this element 0. So A31 position means that position 31, that become 0. So now we have to do again the row operation. So now again, so pivot element is same, A11 is equal to 2. Now we have to do the row operation. So again, so this is the second multiplier, so that is M2. So that is nothing but, so A31 is nothing but that is what, A31 2 and A11 2. So 2 by 2, that is 1. Now we have to do this operation. So row 3 become that after doing operation, so we'll get new row 3. So row 3 is actually row 3 minus 2 by 2 into R1. So multiplier value will not be changed, so that will be constant. So that the row 1 will be as it is, row 2 will be as it is. Now here 2 minus 2 by 2 into 2 minus 3 in minus 2 by 2 into 3. So we have to do that. So this is 2, first row 1 is the multiplier, row 1 again second element, again row 1, this is row 1. Okay, so now after doing that same operation, means earlier same way we did we'll do the operation, and finally we'll get this. So 2 3 minus 1 5 as it is, second row will not change, and this element become 0, and 0 minus 6 3 minus 3. Now already we did that 0, this 0. Now next will be we are going to, means I'm going to make this element 0. So A32 dash means new element, so that I'm going to 0. Okay, now again operation. So now here, so A22 here, A22 become that new pivot element, so that is minus 2. Now again we will get that multiply A dash 32, so that is minus 6, and A dash 22, so that is minus 2. So we'll get new multiply, so M3. So now again we'll do the same way, that same operation. So now here 0, already this element R3 element 0 minus 6 by minus 2. Okay, so that is 3 into that second row, that is R2, that is 0. So now we will get 0, and minus 6 minus 6 by minus 2 into 2, so we will get 0. And similar way we will do that operation. Okay, and after that we'll get this 2 3 minus 1 5 as it is, this will not change, and then row 3 will be changed. So this element and this element become 0. Now finally this is the diagonal element, below the diagonal element we will get all this element 0. So now by the row operation we form that upper triangular matrix. Now we have to do the back substitution. So from this back substitution we will get the value of x, y, z. Now in that equation, so row 3, so from the row 3 we will get 6z is equal to 18, because x and y coefficient values are 0. So means here 0x plus 0y plus 6z is equal to 18. So here from here to here 6z is equal to 18, so z is equal to 3. Now from the second row we'll have, so 0x, okay, minus 2y minus z equal to minus 7. So y is equal to minus 7 plus z minus 2. Now y will get 2. So y is equal to 2, that we will get. And first row, so that will be 2x plus 3y minus z is equal to 5. So we know y value and z value, we plug that, so we'll get x is equal to 1. So from that we'll get the solution of that simultaneous equation. So final answer, x is equal to 1, y is equal to 2, and z is equal to 3. Now if you put that equation, so this first equation, so 2 into 1, so 2 plus 3 into 2, 6. Okay, 6 plus 2, 8 minus z, z is equal to 3. So we will get 5. So ultimately, so our answer is actually correct. Now follow the procedure. Okay, if you get that 4 by 4 that matrix or 4 simultaneous equation, follow the same procedure, you will get the answer. That's it. Thank you.